if you have a fifth grade students, and you show that students this question, and you can ask the fifth grader to answer this question. One is that you find the area between those nice segments and semicircles and the x-axis. But the fifth grader can work this out, no? And how calculus can work this out. And now you're moving your student to understand calculus way before they see the word calculus in high school, senior year, or in college, first year. That's it. Hello everyone, this is Dr. Marrero from Math Topics. Welcome to this channel. If this is your first time, give us 10 minutes or less. And then if you like it, don't forget to subscribe, don't forget to share, don't forget to be part of this community. If you have a fifth grade students, and you show that students this question right here, exactly this question right here, that is a calculus question. It's from the integration content of calculus AB. And you can ask the fifth grader to answer this question. And I can tell you that if you walk your fifth grader through a very nice conversation, the fifth grader can be doing calculus at the end of the lesson or at the end of the class. What do you think? Let's see it. You see the question right there on the board. The function f is right there. It's a function. It's comprised of a semicircle and a piecewise linear segment. What is the value of the integral from 2 to 7 of the function f of x dx? Write your answer in simplest form. Okay, what is the value of the integral? Okay, your fifth grader doesn't know that notation, of course. You're not going to tell the fifth grader that what I have said right now, the origin of the question. You're going to show your fifth grader just the graph on the coordinate system of that function that later on the fifth grader will see that is a function. They have no idea what is the concept of a function in fifth grade. Not yet. So you're not going to talk about function. You're not going to talk about integration. You're not going to talk about those symbols. You're going to ask instead your fifth grader that find the area between the x-axis and this nice, funny picture. So the x-axis is right here. So let me highlight it. You have the x-axis. You're going to tell the fifth grader that this is the x-axis, And you're going to tell the fifth grader to find the area between this beautiful curve and the x-axis. So your fifth grader is going to start thinking about this area here, okay? And between this beautiful line segment and the x-axis. So your fifth grader is going to start thinking about something like this, no? Okay, below the segment, and something like this below the segment. Because it's between the nice picture, the two segments, and the x-axis, and the semicircle and the x-axis. That's why you're going to ask your fifth grader. Immediately, this is geometry. This is not calculus. Remember, your fifth grader doesn't know about the integration, doesn't know about the area under the curve, doesn't know about the notation f of x, doesn't know about what is f of x dx. Nothing. Just ask. You have the coordinate system. They know a coordinate system when they're in fifth grade, x and y. They know the integers. They know the real numbers. They know a lot of things. They know the area of the circle, how to find it. They know how to find the area of a triangle, because that's what they need here. The area of the triangle, the area of the circle. That's it. And you're going to say, what I want is that you find the area between those nice segments and semicircles and the x-axis. That's it. That's the conversation. Beautiful. Let's see how the fifth grader can work this out, no? And how calculus can work this out. And now you're moving your student to understand calculus way before they see the word calculus in high school, senior year, or in college, first year. That's it. Now let's talk about calculus. We are going to start finding the reality. The question itself says that you have to find the integral from 2 to 7 of the function f dx. So we have a specific interval right here. And the interval is from number 2 all the way to 7. So remember, our fifth grader was able to find the area of the circle. And our fifth grader was able to divide by 2, because this is a semicircle. Our fifth grader was able to find the area of the triangle right here on the left, by using base times height divided by 2. Okay, very easy. Our fifth grader is able to count the units of the base 1, 2, 3, 4, 5. The height 2, so it's 5 times 2 divided by 2. Our fifth grader was able to create here another triangle below the x-axis and count the units of the base 1 and 2 and the units of the height 1, 2, 3, 4, 5, 6 multiplied divided by 2. Our fifth grader was able to calculate all the 3 areas of this nice picture and the x-axis. Okay, the boundaries of the picture, the boundaries of the segment, and it's important the vocabulary with your fifth grader. The boundaries of this image, which is this segment right here, and the x-axis. Okay, and the boundaries of this semicircle with the x-axis and the curve, and of course the last triangle. So the fifth grader was able to do all of that. And the fifth grader also, you can ask the fifth grader to find the total area. So the total area for a fifth grader is the sum of all the areas, the sum of the triangle, the semicircle, and the final triangle. That's it. The fifth grader is doing calculus. He or she doesn't know that he's doing calculus, but he's doing calculus. It's really doing calculus. Now, when you go back to calculus and that fifth grader reach your classroom and you show the picture again of the same thing, beautiful, nice picture, but now the fifth grader knows that is a function. Know more about function notation. Your fifth grader knows now what is this notation right here, which is no more than the area under the curve in that particular interval, 2 to 7. So it's only from 2 to 7. That's it. And from 2 to 7, your former fifth grader now understand that the area is not the whole semicircle, is not the area of this triangle over here. It's just that interval above the x-axis and below the x-axis. Very interesting. That's it. We don't need everything. We just need between 2 and 7. And your fifth grader that now is taking calculus knows the definition of one of the ideas, of one of the big ideas of calculus, which is integration, accumulation, area under the curve. That's the conversation. And now your fifth graders is able to manipulate symbols. Your fifth graders is able now to understand notation. which is another complex structures in the process of learning mathematics. And now the area under the curve, that curve is that my function f of x. And because it's an area, it's a product, f of x dx. And now my fifth grader, my former fifth graders, is able to separate the interval from 2 to 5 of the function f of x dx. And basically, because this is one curve, that is 1/4 of a circle. Our former fifth grader will be able to do that. Plus the integral from 5 to 7 of the same function f of x, but in that particular interval is that triangle, that right triangle below the x-axis. That's it. Tell me if it's not ideal to learn math, to learn calculus. Tell me if it's not ideal to get a fifth grader and start doing this in fifth grade and move that student in that perception of the mathematics. You will see significant improvement in mental processes. You will see significant improvement in math fluency, in conceptual mathematics, in procedural mathematics, in understanding math structure. One of the biggest problems in math education. Now, we're going to continue with the integration layer. I don't want to spend time in this video. It's just to show you the pedagogy behind calculus and how can we prepare students since they are in elementary school with big ideas of calculus. You can separate here the integration 2 to 5 of the function f from 2 to 5 is the area of the circle, pi times r squared, but divided by 4 because this is 1/4 of the circle. And this is when the foundation of geometry is coming into play. The area formula for the circle and the picture of the circle and the semicircle and 1/4 of a circle. That's it. The rest is integration rules. Okay, integration rules. Pi times r. What is r? Right, is the radius of the circle, which is 1, 2, and 3. 3 to the power of 2. 3 to the power of 2, 9 times pi over 4. Because this is basically constant times constant. That's it. And the second interval, which is from 5 to 7, is the area of the triangle based on pi divided by 2 that our former fifth grader knows perfectly. And that minus in front, look at the minus right there, is very powerful. Why is very powerful? Because that's the area under the x-axis. So we have 1/2, the base, which is 2, times the height, which is 6. 2 times 6, 12. 12 divided by 2 is 6. But that answer is negative. And our fifth grader cannot see that in fifth grade, but now can understand it better because that triangle, that area right there, is under the x-axis. And we have -6. Right here. And finally, our former fifth grader will be doing exactly the same. Is going to add up the two individual integrals value. For our fifth grader, is just adding the areas of those plane figures. -6 plus 9 pi over 4. -6 plus 9 pi over 4. That's it. And that's the answer. And that's the end of the conversation with your fifth grader. Years after your first conversation about the beautiful picture, the x-axis, and find the area of those very, very well-known plane figures. If you like the video, don't forget to subscribe. Don't forget to visit our playlist. How do I teach math? How do I learn math? You're going to see beautiful things there. And a playlist for math teachers. And our channel in general. And also be part of the math topics membership. Thank you for more resources. Thank you for watching. See you in the next video.